So here we have a couple of problems based on finding the required terms for the given geometric progression. So let's begin. So here in this geometric progression given by 2, 1/2, 1/4, here we'll need to find out that particular term whose value is 1 over 128. So let's begin. Here we are being provided with the first term. The value is 2. We can determine the common ratio. All we have to do is take the second term and divide it by the first term, which is 1 over 2. Then the nth term, the term that we need to obtain, it's given that its value is 1 over 128. Now we can use the fact that the nth term of a geometric progression is given by the first term times the common ratio r raised to the power of n minus 1. So we'll substitute the value here. So here 1 over 128, this is equals to 2 multiplied to the common ratio r, which is half raised to the power of n minus 1. So we can divide both sides with 2. So this is going to give us 1 over 256. We have 1 over 256 equals to half raised to the power of n minus 1. Now we know that 2 raised to the power of 8. So this is going to be equals to 256. So that means we can rewrite 1 over 256 as 1 over 2 raised to the power of 8 equals to half raised to the power of n minus 1. Now in this equation we see that the base is half and that's equal, so that the power must be equal. So that means n minus 1 must be equals to 8, and solving for n we get n value equals to 9. So that means the ninth term of this particular geometric progression is going to be 1 over 128. Problem number 2. So here we need to obtain the term of the geometric progression having a value of 5120. So let's begin. So our first term is 5. The common ratio is going to be 10 divided by 5, which is equals to 2. Therefore, the nth term, which is given by 5120, has a value a times r raised to the power of n minus 1. So here 5120 equals to the first term 5 multiplied to 2 raised to the power of n minus 1. We'll divide both sides with 5. So where 5120 divided by 5 equals to 2 raised to the power of n minus 1. So 5120 divided by 5, that's 1024. This equals to 2 raised to the power of n minus 1. Now we know that 2 raised to the power of 10, so that's 1024. This is equals to 2 raised to the power of n minus 1. Since the base are exactly the same, so we can equate the power. So n minus 1 will be equals to 10. So that means the 11th term of the given geometric progression is going to have a value 5120. Let's move on to the third problem. So let's obtain the term of the geometric progression having a value 512 divided by 729. So here our first term a, that is 18. The common ratio r, then we consider the second term, which is negative 12, and divided by the first term, which is 18. Now we know that 6 times 2 is 12 and 6 times 3 is 18. So that means our common ratio is going to be negative 2/3. Here the nth term is also given, has a value of 512 divided by 729. Now we have the nth term equals to a times r raised to the power of n minus 1, which gives us 512 divided by 729 equals to 18 times negative 2 over 3 raised to the power of n minus 1. Now we'll divide both sides by 18. So we have 512 divided by 729 times 18 equals to negative 2/3 raised to the power of n minus 1. So this is going to give us a value 256 divided by 6561 equals to negative 2/3 raised to the power of n minus 1. Now we know that 2 raised to the power of 8 has a value 256 and 3 raised to the power of 8 has a value of 6561. This will be equals to negative 2 over 3 raised to the power of n minus 1. Now we can rewrite the expression on the left hand side as 2 over 3, negative 2 over 3 raised to the power of 8 equals to negative 2 over 3 raised to the power of n minus 1. Since the base is exactly the same, so we can equate the powers to get n minus 1 equals to 8, or solving for n, we have n equals to 9. That means the ninth term of the given geometric progression is going to have a value 512 divided by 729. Let's move on to the final problem. So problem number 4. Here we have the first term a, which is square root of 2. The common ratio is 1 over square root of 2, the second term, divided by the first term, which is square root of 2. So that means we have 1 over square root of 2 multiplied to 1 over square root of 2. This is going to give us a value half. The nth term is given as 1 over 512 times square root of 2. And now, using the formula for the nth term, an equals to a times r raised to the power of n minus 1. So I have 1 divided by 512 times square root of 2 equals to the first term, which is square root of 2 times the common ratio half raised to the power of n minus 1. So we can cross multiply to get 1 over 512 times square root of 2 multiplied to square root of 2, which equals to half raised to the power of n minus 1. This is going to give us 1 divided by, so square root of 2 multiplied to square root of 2. So this value is 2, and 2 times 512 is 1024 equals to half raised to the power of n minus 1. Now 1024, this is 2 raised to the power of 10, or we can simply have half raised to the power of 10 equals to half raised to the power of n minus 1. So equating the powers, we have n minus 1 equals to 10, which implies that the n value is equals to 11. That means the 11th term of our given geometric progression is going to have a value 1 over 512 and times square root of